Yes. Okay. So, starting with number 4, what is special about the electric field inside a conductor? Okay, here's what's special about it. It is 0. Inside a conductor, the electric field is 0. Now, you might be saying to yourself, how is that possible? That looks like it says echo, but it doesn't. It says E equals 0. You might be saying to yourself, well, how is that possible? A conductor allows charge to go through it. How can the charge be going through something and have an electric field of 0? Well, here's how. The charge stays on the outside of conductors. Stays on the outside of conductors. And now you might be saying, well, okay, so if it's on the outside of a conductor, why is the field inside 0? Shouldn't there be a huge amount of field if there's all these charges around it? Well, remember, electrons attract the field, so all of them are going to suck the field into themselves. And for some slightly more complicated reasons, which I'll show you in a video here in a second, the electrons basically cancel out all of these charges acting on each other. And that is what causes this to happen, is you basically have these charges canceling out each other's field, and the field inside between them, because they're evenly distributed, is going to be 0. Now, there's some really fun implications of this, and that is something called electric shielding. Basically, electric shielding is where you basically contain an object inside a conductor where there's no field. So if I have something called a Faraday cage, where I have this big, basic box, and it doesn't have to be entirely enclosed. It can be, it needs to be, there is a limit as to how open it can be. But if you essentially think of it as like a cage or something like that. It is called a Faraday cage after all. Basically, you can allow electric charge to go into this, and the person inside will be completely protected because the electric field acting on them will be 0. There is no electric field inside the cage. So, this gives me a great example. So, how many people have heard the thing that the safest place to be in a lightning storm is a car? How many people have heard that? Safest place to be in a lightning storm is a car. Not as many as I would have expected. Okay, hey, guess what? The safest place to be in a lightning storm is a car. Assuming winds aren't a factor, like assuming there's not other things. Obviously, if like winds are a factor, you don't want to be in a car in case like a tree is going to fall on you or something like that. But if it's just a lightning storm and like rain and stuff like that, car is the safest place to be. Now, for those of you who have heard that, why is it? Why? Yeah, it's frequently made out of, what is it that is made out of that people say? The what? The what? The what? The what?
The car material.
Well, okay, no. No? What I've usually heard people say is that the tires are made of rubber. That's what I've usually heard. People say the tires are made of rubber. Rubber is a good insulator, and that is absolutely true. But here's the thing. Enough non-conductor things get struck by lightning that it is not the rubber. And in fact, cars do get struck by lightning. Okay? I had a student in a period tell me that their mother was in a car that got struck by lightning, and she ended up being fine. Didn't even get like any, wasn't even like me where I got hit by lightning, but I ended up being fine in the end. It was like the car got hit, the car completely died, all the electronics went out in the car, but nothing happened to her. She didn't even get like the tiniest little spark. It is not because the tires are rubber. Rubber doesn't stop lightning. Lightning is billions of volts. Okay, doesn't care what the rubber is. Doesn't care at all. Okay, The reason why cars are the safest place to be in a lightning storm is because of this, electric shielding. Cars are conductors, so you guys are right. The material of the car matters. Cars are made out of mostly, usually, aluminum or kind of some really light steel or carbon fiber in some fancy schwanky cars, which I'm assuming none of you have. But most cars are made out of light conductive materials, metals. And so that means that inside the car, the electric field is zero. When the lightning hits the car, which isn't that often, but if it does hit the car, it'll hit the car and it will go around the car on the outside edge. It'll go around through the cage. It will not go into the car because the field inside the car is zero, so the charge won't go in there. There is no electric effect inside the car. You can't get shocked if you're touching it. If the window's open, the lightning won't come into it. It'll hit the car and go around because inside the electric field is going to be zero. And that's how electron shielding works, and it has to do with this idea of electric field. So let me show you an example of this.